good animation and all that kind of stuff. So you might want to check those out as well. Okay, so we are going to deal with in this video here, the basics of statistics. Okay, and it's not too bad. It won't be a long video. Oh, it'll probably be a little boring. But anyway, here we go. Statistics is the science of extracting information from sample data to draw conclusions and or make decisions. That's the whole thing, right? Like if you're going to let's say there's an election coming up in Canada, and there's not enough money there to go and individually ask everybody. So what you do is you take a sample of the Canadian population, and then you project that sample onto the Canadian population, right? But is stats always right? No. There's something there called a margin of error that we'll get into there later on. Plus or minus 3%, these kinds of things here. But statistics refers to a set of procedures and methods, design a research study, collect data, organize data, summarize data, analyze the data, interpret data results, draw conclusions, and make a decision. Again, you design a research study, right? What is it you're going to study? You collect the data. You organize the data. You make the data sing, right? And what is the data saying to you? Summarize the data. Analyze it. What does it mean? What is it exactly saying to you? Interpret the data results, draw conclusions, and make a decision. So this is what statistics, all of these different aspects are part of statistics. Alluded to there earlier, there's the population. Okay, that is what we want to study, right? But we just don't have enough money to study and ask all these people. So what we do is we take a sample. All right, and sample refers to a subset of data. Okay. The population is the set of all possible individuals, objects, or measures of items of interest. The sample is a subset, right, as we just saw. So examples here, all students enrolled in a post-secondary health science program in Canada, and we take a sample of 200 of those students, okay? And, all right, Harley, you want to go outside? Of course you want to go outside when I'm making a video. Beagles, oh my goodness. Make sure if you get a beagle, make sure you have a top for your garbage bin for sure. Where are we here? Basic statistical terminology. There is something there called a parameter, which is a summary value that describes the population, as well as an individual statistic, which is a summary value that describes the sample. Okay, let's have a look here. So, going back to our original, right? A parameter of the population, statistic there is for the sample. The mean is denoted by mu. You'll see that one right there. Okay, that's the mean. That is the average value. Okay, which we'll get into there week 4. And the standard deviation is denoted by sigma. And we'll get into that as well. These are two very important parameters. Okay, we'll be dealing with this basically the entire rest of the course. Okay, and then you have the mean of the sample, which is denoted there by x bar. And then you have the standard deviation of the sample, which is denoted by a small s. Okay, parameter, statistic. So, identifying population, sample, parameter, and statistic. So in an attempt to estimate the GPA of a typical student in a business school, a professor collects data about all students whose student ID ends with the digit 5 and found that their average GPA was 3.23. Okay. The school's dean later reported the average GPA of all students in the school to be 3.27. Okay. Identify the population, sample, parameter, and statistic in this. You'll remember there that when you're talking population, right? And then you got the sample, parameter, that deals with population information, and an individual statistic, that one deals with the sample information. Okay? So, solution, identifying population. Okay, all these different aspects there. So all the students in the business school, that is your population. The sample there is the, and there's different kinds of samples, which we'll get into there. There's random sample, cluster sample. You know what I mean? Because if you're going to take, going back to the election example there, if you take a sample of people from one neighborhood in Barrie, could you very well project that across all of Canada, right? You've got Quebec, where people speak French. You've got people up north there in Nunavut there. You know, you've got people there in Vancouver, Calgary, Regina, Winnipeg, New Brunswick, Newfoundland. Are all of these people going to think alike? Well, probably not. So you'd have to take a sample, probably from a smaller sample from all the different provinces and territories. And but we'll get into different kinds of sample there. The parameter, okay, again, that deals with the population, and that was given there by the dean's. The dean's office there gave the GPA of all students in business school is 3.27. But the GPA of the students there with ID ending with a digit 5 was 3.23. Okay? So there's your 4 aspects there that we were looking at. 1, 2, 3, and 4. Good. Moving on. Population, all students in the business school. Sample, students there ending, ID numbers ending with 5. Parameter. Okay, that was the GPA of all the students in business. Statistic there, that was these guys here. Just a little summary. Other important statistical terminology: an element, a specific item, object, or individual in a population from which data is collected. A population thus consists of all elements of study. Okay, a specific item, object, or individual in a population from which the data is collected. That is what we call an element. Census, the process of collecting information about every element in a population. Sample survey or sampling, the process of collecting information about the elements in a sample. Okay, so when a survey focuses on responses to only one question, it is often referred to as a poll. So when a survey only has one question, it's a poll. Okay. Attribute, a characteristic of the data that can be observed, measured, or categorized. An attribute would be an age, height, sex, blood type. Okay, that's what we call an attribute. And a variable, a variable is an attribute that may vary from one data value to another. Okay, we'll get more into these as we go. Constant, an attribute that does not change. Observation, a value or measurement obtained from a variable. Okay, data or data set, a collection of observations or measurements. Cross-sectional data, data collected at a single point in time. Okay, an example here, collecting data on the ages of students during their first class. Okay, cross-sectional data. Okay, collecting all the data at the same point in time. Time series data, data collected successively over a period of time. Daily blood glucose levels of a diabetic patient, monthly COVID-19 antibody titers. Even the whole idea of you're going back yearly. I remember reading a study there. They were looking at cancer patients, and they would go back and visit them again year after year after year after year, right? No, they weren't cancer patients. They were looking at whether they had developed cancer, okay? And that's what we call time series data. So, identifying an element, an observation, the attribute, and whether it is a variable or a constant, and the data in the following table, outlining the weights of newborn babies in local hospital. So here we have 4 people: Liam, Oliver, Amelia, Mila. And then we have their weights: 3.6 kg, 3.8, 2.9, and 3.2. So we're looking at these guys here, as well as data. Can you identify them? You can pause the video, have a look, see if you can go back in the PowerPoint there, or you can just go to the next slide here and you can see what's going on here. So an element in this case here, okay, would be the individuals of study. Okay, an attribute, weight, height. Okay, and in this case here, it is the variable, because the variable can change and does change per individual. An individual data point, okay, 3.6, data set, okay, and as well the observation there, okay. Somebody has to go and observe and take note that Amelia's weight was 2.9 kg. Okay. So again, there's the summary, okay, of what we just talked about. Good stuff. Sources of data. Primary data refers to the data collected by the researcher for a specific purpose. Okay, primary data refers to the data collected by the researcher for a specific purpose. Secondary data, though, refers to the available data collected previously for some other purpose by someone else. That's a huge thing. You don't even have to conduct a study. You can just go and use somebody else's data, okay, that was collected for a different purpose other than your own study. You can use that data, okay, and we call that their secondary data. So primary data, information collected through experiments, observations, interviews, questionnaires, surveys by mail, okay. You have a study, you organize the study, you are organizing the data collection for your study. Secondary study, though, information made available to the researcher via the results of a census, Statistics Canada, websites, journals, research articles, previously done studies that collected data. You know, it was primary data for these people, but then now the study's done, conclusion has been made, those researchers have moved on. You can still use their data for a secondary purpose. Okay. Again, you know, the same thing. We're just kind of walking over the same carpet here. Primary data is expensive. Oh yeah, you know what I mean? You got to pay people to do this, you got to pay yourself, and as well as time consuming. Okay? Easier to ensure that it is reliable and accurate because you are the one collecting it for your purpose. Secondary data, sure, it's economical, easy and available. It's already done, it's there, it's ready to be used again. But can be difficult to ensure its unknown reliability and accuracy. Why? Because somebody else did it, right? And how did they collect that data? Were they scrupulous? Were they meticulous in their data keeping? Who's to say, right? You the whole job there. You want the job done right. Do it yourself. But again, primary data, very expensive. Identifying primary and secondary sources. Okay, doctor collects data from his patients there about COVID symptoms. A professor asks his students to estimate the quality of a new online class. You know, you're getting that data firsthand. Secondary data, a doctor uses a journal article published by researchers studying the effects, okay, of the COVID vaccine. You know, that was 5-6 years ago. Can you believe COVID was like, yeah, crazy. Can't believe it. A dean is deciding whether or not to introduce a new online educational program basing on data gathered by the professors of his department. Okay. Good. Moving on. Descriptive statistics. You'll need this information there for your assignment 1. Are often presented as single value tables or charts. okay, or graphs even that help simplify, organize, and visualize, analyzing summaries and making sense of the data. This is the whole idea, right? Like when you get data, you go out there and you ask people, you get your surveys, you get your data. It's mashed potatoes. Doesn't make any sense, right? You have to organize this data, and that's probably the fundamental instrument there of why we use statistics, to let the data sing. What are the numbers actually saying to you, right? And once you organize the data into tables, charts, graphs, you're able there to determine the mean, the median, the mode, the range, the standard deviation. What is the data saying? Are the people thinking alike, or are the people thinking very differently? Okay. Inferential statistics makes estimations, interpretations, or predictions and draw conclusions on generalizations about a population by studying a sample obtained from that population. So again, descriptive, okay, presented, okay. Inferential, though, you're inferring, right? You're making an estimation, you're interpreting, there's an opinion here, right? Descriptive, it is what it is. The data is what it is. There's really no opinion going on here. There is a mean, that's mathematical. There is a median, there is a mode. But inferential, there's a little bit of leeway here. Inferential statistics attempts to use results from the sample data to describe the population data that we do not have. So this is the whole idea here. The sample data, which is not the population, the sample data is just the sample, and it has a mean, it has a mode, it has all this information about it, but it's just the sample. How dare we try and project this onto the population? But that's what statistics is. Okay. Analyzing the data from the sample using probability, estimation, confidence intervals, plus or minus 3%, hypothesis testing, ooh, love it, okay, and regression analysis. Okay, so descriptive statistics serves to describe, okay, you can see it right there. Inferential statistics is used to draw conclusions, okay, describe what the data is telling me. Okay, inferential, you're kind of limited in your data, okay, because it's coming from the sample, so you're going to try and draw conclusions from it, right? Descriptive, organize, visual, analyze, summarize. Inferential, estimation, interpretation, prediction, and decisions. Inferential infers to infer. Okay, good. Some more examples here. They're great. Okay, descriptive there. A suburban primary care clinic has a high percentage of patients with a BMI over 25. Okay, it's stating something. 30% of the students in the statistics class are in the nursing program. Okay, stating something. That's descriptive. Inferential, the world population is expected to reach 9.7 billion by 2050. Okay, you see the difference here? Okay. A study shows that using online tools to study improves college students' grades by up to 40%. Again, this is not exact. You're trying to draw a conclusion from this information. Here, you've kind of already got your conclusion. It's stating something. Analytics is categorized into descriptive, diagnostic, predictive, and prescriptive. Okay, so how is the data behaving? There's your descriptive. Diagnostic. Why is it behaving this way? Because that is a key factor behind statistics. We always like to know why things are happening. We're not always privy to that information, but we love to know why things are happening. And then we've got predictive, right? That's basically the whole aspect of science is repetition. right, is being able to predict, okay, what is going to happen, because that's, the state of the universe. Science loves regularity. How will it behave in the future? Okay, or in some other setting. And then we have prescriptive. What do we do as a result of this data behavior? How can we use this information to better humankind? Okay. There they are again, just some examples here. Again, descriptive, what symptoms is the patient experiencing? What are the values of the measurements? Okay, need the information. Diagnostic, what do the various symptoms and measurements indicate is happening? Right, there's that why. Predictive, what will likely happen if certain treatments are or are not applied? Right, let's go back to here. How will it behave in the future? And then, what course of action should be recommended to the patient? How can we make the patient's lives better? How can we use this information there to save more lives? Okay. So when researchers desire to know the value of a particular variable in a population, they make use of a study. So there are statistical studies, and we break these up into experimental, observational, surveys, and censuses. Okay. Experimental studies, or simply experiments, involve manipulating the variable of a particular variable. Okay, sorry, involve manipulating the value of a particular variable, and this is called a treatment, right? The if let's say you have, I just invented a new type of soil, right? And I think that this soil is going to revolutionize gardening, right? So how would you determine whether my soil is better than just, the soil you could get at Walmart or the soil you can get from your backyard? Well, what you would do is you would get 3 or 4 different buckets. You'd fill one with my soil, you'd fill one with soil there from Walmart, you'd fill one from soil from your backyard. You'd put in the same seed, right? You would give them all the same water, the same sunlight, right? So eventually you would get your results. Whether my soil was any good or not is irrelevant for my point here, but you have to think here, what was the only thing that we tweaked in that experiment? The seed was the same, the water was the same, the light was the same, the bucket was the same. The only thing we treated, and that is that word there. The only thing that we changed was the soil. Okay, and that's what we mean here. An experiment involves manipulating the value of a particular variable. Okay, what did we tweak in the experiment to elicit a particular response, right? So clinical drug trial, in which the efficacy of a new drug is tested on participants used against a specific disease, right? So you have there could be confounding variables, or variables other than the treatment, that may impact the response. And this is the number one problem with dealing with an experiment, is confounding variables, right? These can be problematic, and an experimenter has to try and remove these because they can interfere with the results. Okay, so the experimental group here, they receive the treatment. Okay, the control group received no treatment. So now you have the experimental group that is maybe receiving this experimental drug. The control group is receiving a placebo pill, a sugar pill, right? And now we monitor them, a couple days or a week after they've been taking this drug. How are these guys doing? What's the effect? And how are these guys doing? What's their effect? Is this drug making them better? Is this sugar pill making them better? It's called the placebo effect. People take a pill, they actually feel better. So if these guys are feeling better, then that's a problem there for this drug. Okay. Right there's your placebo effect. Okay. There are blinded experiments ensuring that patients do not know whether they are in the experiment or control group. You want to keep the patient out of it. Okay? And there's even double-blind experiments where even the researcher doesn't even know who's in a control group or who's in the experimental. Why? Because money sadly rules everything, and it shouldn't be the way it is. Okay? Science, knowledge, the truth should rule everything. But sadly, their money plays an impact, so experimenters may try and manipulate the data so that if the data goes a certain way, then all of a sudden this experimenter just discovered a new drug, and now they're going to be bazillionaires, right? Can be problematic, all right? We don't want any bias, okay? Bias. That one there is the cause of all trouble when it comes to science and truth, okay? We never want bias. Moving on here, observational studies here are statistical studies where the researchers observe and measure the results of a particular variable in a sample of the population without attempting to influence or manipulate the variable in any way. Blah, blah, blah. You're watching a bunch of giraffes, live their lives. The giraffes don't even know that you're there. Okay, you're watching children on a playground and how they interact there on a particular, whatever. Okay, but you are not interacting with them. They don't even know you're there. You're not influencing the study in any way. You're just observing them. Okay, there's some examples there. Okay, study there to determine the success rate of joint replacement surgeries. Study investigating the impact of COVID-19 on cognitive function in adults. Okay, where the researcher is not a part of the study in any way, just observing. Then there are surveys, which are statistical studies where data is collected from a sample, and censes there are statistical studies where data is collected from the entire pop. So surveys, sample, census, pop. Okay. There are two instances where surveys and census are very effective in obtaining demographic information. I think that there was just, I had to fill one out there, the Canada Census forms there about a month ago. You got to fill them out online and do all that kind of stuff. It's all about demographics. How many people live in your house? In your house? Where's everyone from? What's their mother tongue? All these kinds of things, right? As well in learning about opinions held by individuals in the population. Okay. Last slide. Responsibilities for researchers in statistical studies. You have a look at these there. Experimental, observational, and survey census. Design the study and select the sample. Absolutely. Have to do that. The experimenter has to do that. Okay. Observe and record results. Well, the experimenter is going to be watching the experiment. The experimenter is going to be watching the patient. Observational study. Survey census, no. It's a little bit disengaged in that regard. Applying a treatment. Remember that treatment? What did we tweak? Holy, there's helicopters and trucks and ambulances and lawnmowers going on. Apologies there for the sound quality. But applying a treatment, what did we tweak to the experiment? That only applies to the experiment. There is no tweaking. Okay, here we're survey census, we're just asking questions. Observational study there, you're just watching, observing, and taking notes. All right, that's chapter 1.1. I hope you all are well. We'll see you guys there for chapter 1.2. Take care. Bye-bye.